Your functions. Starting off a definition, a function is a rule for a relationship between an input or independent quantity, it's usually known as X, if you think about your graphing, and an output or dependent quantity, which is usually our Y value. So each input, our independent quantity, X, determines one and only one output value, and that's usually Y. We say the output is a function of the input, or Y is a function of X. So this is read as Y equals the function of X. This is not multiplying F times X. This is a representation of Y is truly a function of X. This is how it's said. Function notation is used to indicate a functional relationship between two quantities. So the function name, and in this case it's F, the input is X, is equal to the output, in this case is Y, would refer to the function F correspond to the ordered pair XY. So if you think of graphing, we've got ordered pairs that go together. The input decides the output, where X is the input variable and Y is the output variable. Be careful when I say this again, because F of X does not mean F times X. We're not solving for F when it comes to this type of thing. A function P of N, and this is a function, gives the wholesale price in dollars of a package of cookies after N packages have sold. So whenever they ask you to interpret the meaning of P of 124 equals 0.8, this means that, well, P of N represents the wholesale price in dollars of a package of cookies. So it's the wholesale price of one of a package of cookies. Okay. N has to do with the number of packages sold. That's not hashtag, it's number of packages sold. Okay. So if we have P of 124, 124 took the place of N, and N is the number of packages sold. So what we can say is after 124 packages have been sold, so after 124 packages of cookies were sold, each package or a package of cookies have a wholesale price of and we've got 0.8. So this is money. This is the wholesale price. So if I were to write 0.8, that's not representing money. So in this case, I need to make it look like money. I need a dollar sign out front, and I need to make sure that I present all the way to the ones place or the hundredths place for my zero, 2 places to the right of the decimal. So after 124 packages of cookies were sold, this is what this means. A package of cookies have a wholesale price of 80 cents. The function C of G represents the cost to produce G gallons of chocolate chunk ice cream. Interpret the meaning of C of 751 equals 160. So C of G is the cost to produce G gallons of ice cream. And where the G was has been replaced with 751. So G is the gallons of chocolate chunk ice cream. So G is the gallons of ice cream. I'm not going to write chocolate chunk because what if you prefer something else? So 751 gallons of ice cream were produced, and the cost is what C of G is, which is 160. So to produce 751 gallons of ice cream would cost $160. And there's my answer. Okay, next is the function d of t. I would like for you to pause with each one of these. As you're going through here, pause the video, attempt to understand it and interpret it yourself, then come back and see what I do. Okay, compare it to what you did. If there's any differences, I hope you've learned something. If there's not, congratulations. The function d of t can be used to approximate the total average credit card debt in a U.S. household in thousands of dollars, T years after 1995. Interpret the meaning of d of 29 equals 21.5. So the function d of t is the total average credit card debt per household in 1,000. So d of t is credit card debt in thousands. And T is the number of years after 1995. So when you're interpreting this, we've got it's 29 years after 1995. I don't want you to write in 29 years or 29 years after 1995. I want you to tell me what year that is. So take 1995, add 29 to it. So in 2024, the total average credit card debt in a U.S. household was what? Don't forget your dollar sign. 21.5. Here's the deal though. This 21.5 is in thousands of dollars. So you have to take 21.5 times 1,000 and you get $21,500. That's it. All right. So for the next one, I would like for you to attempt this one. And then, I mean, you can attempt this one as well, but this one's a little bit more difficult, but I think you can handle this one at this point. So pause the video and attempt A. It's a function d of h, gives the number of miles Billy has driven in a car from his house h hours after leaving his house. So you've got, okay, pause the video, attempt it yourself. So d of h is the number of miles Billy has driven. And h is the hours after leaving house. So to interpret this, d of 4, so the h, the 4 is replaced the h, so 4 hours after leaving his house. Billy has driven 160 miles. Okay. The next one is the same concept. D of h is the number of miles driven, which is going to be 2. And h is the hours after leaving. And this is of 0.1. So this is where the issue comes to play is the 0.1. If the h is representing hours and we have a decimal of an hour, that means it's going to have to do with minutes. So we need to know how many minutes there are in an hour, and there's 60. So to find out the time, I'm going to multiply 0.1 times 60. And I get 0.6. Well, I get, oh, hold on. Let me use my calculator. So sorry. get there eventually. Where is my calculator? I'm pausing. Hold on. Okay, I don't need to do that. I can just do this. It's been 6 minutes. All right, because this is minutes and this is 0.1 of an hour. All right, so six minutes after leaving his house, Billy has driven 2 miles. Not going very fast. All right, next one. When we work with functions, there are 2 typical things we do. We either evaluate or we solve. So evaluating a function means you start with an input, you have an X, and you plug it in to find out what the output is. There will only be one answer given. Each function can only have one answer as an output. So each input can only have one output. But if you're solving a function, that means you're looking for the input. They're giving you the output. They're giving you the Y, and they're looking for what is the input. So your result is you're trying to get and figure out which inputs would give that output. Solving can give you more than one answer if you're looking for different inputs. Okay. So we're going to look at a table, and you will have one like this on your test. So you're given a function g of t. Here's the function. And this is going to be your output. Your input is going to be your t variable. So when you evaluate, you're given the input and you're looking for your output. All right. So g of 1. What I like to do is explain to people this 1 has replaced t, okay, in the function itself. So what that tells me is when t is equal to 1, what is the function? And this is the question I always ask myself. When t is equal to 1, what's g of t? And hopefully that helps you see it better. So when t is equal to 1, what is g of t? All right. And that is 24. So g of t, so g of 1 is 24. All right. And there can only be one answer there. If we evaluate g of 3, I would like for you to pause the video, attempt this one yourself, and then come back to see how I do it. Okay. So evaluating g of 3, this is when t is equal to 3, what's g of t? So g of 3, when t is 3, what's g of t? It's 24. Okay. The next one is determine t when g of t is 24. This is solving. We're looking for the input. We're looking to see what t. So when g of t, and this is the question I asked myself, when g of t is equal to 24, what's t? All right. So when g of t is 24, what is t? T is 1. But hold the phone. There's another 24 here for g of t, and that input is 3. Now you could have either written it this way, or you could write g of 1 is equal to 24, comma, g of 3 is equal to 24. They're both correct in this manner. All right, tag your it. I would like for you to go find determine t when g of t equals 3. Pause the video and then come back to see how I do it. All right, so now when g of t is equal to 3, when g of t is equal to 3, what's t? Well, in this case, t is 2. Is there another 3? Yes, there is. G of t is equal to 3 here. T is 6. Or you could write g of 2 is equal to 3. G of 6 is equal to 3. Either one works perfectly. Okay. Let me know if you have any questions on that. Sometimes a graph can help us understand a function. Usually graphs are drawn with the input, what you start with on the horizontal axis, the x-axis, side to side, and the output, what you get out of it on the vertical axis or the y-axis. okay, up and down one. The most common type of graph shows the X horizontal and the Y vertical. When that's the case, we say that Y is a function of X. So where this Y is, it's also f of X, right? And then this one is our X. All right, to evaluate, let me finish this. Or we write Y equals f of X, which means the value of Y totally depends on what X is. To evaluate a function using a graph, you find the input value on the horizontal axis, and then you look up to see what the output is that matches on the graph. To solve a function, you instead start with the output. So where is it hitting on the y-axis, the vertical axis, then look to see where it hits on the horizontal, the x-axis. So let's come down here and do these. I'm going to do evaluate f of -1. And when we're doing any of these, they're all relating to ordered pairs. So -1 on this graph has a y value that matches it. Okay. So if you think of this as f of x equals y, then we're looking at f of -1 is equal to what? And what this means is we've got a -1 for our input. What is the output on this graph? All right, so I'm going to come over here and find my -1 and my x values, find that on my graph right here, and then I look to see where is that along the y-axis, and that is 4. So I have -1, 4 as my point. I would like for you to pause the video and attempt the next one yourself. Evaluate f of 3. So this is when x is 3, what is the y value? Or you could write f of 3, nope, is equal to, all right, I need to find 3 on the x, 1, 2, 3, come down and find that on the graph itself, and then look to see where it's hitting on the y-axis, and that is at -4. All right, next one, determine x when f of x is 0. What this means is when the y is equal to 0, when this y is equal to 0, which is right here, right? What is x? So when y is equal to 0, what is x? All right, well, we have to just come up here and find out. So the x-axis itself is 0 for y. All right, so where is it hitting on the x-axis? Right there. And what value, place value is that for x? That is 1. So x equals 1, or you could write 1, 0. Right? I'd like for you to pause the video and do the next one yourself. Determine x when f of x is 6. So I need to find where y is 6. Here is where y is 6. Where is that on the line? Right there. And where does that correspond? What is this point for my ordered pair if 6 is my y value? What is my x? And that is going to be -2. So x equals -2. All right, we've done those 4. I would like for you to come down here, pause the video, attempt all of these yourself. You can do one at a time if you'd like. I'm just going to continue rolling through them. But I really want you to attempt to do these on your own so that you can see where the mistakes are, if there are any, okay? We're going to start with evaluating f of 0. This means when x is 0, what is y? All right, so here is where x is 0. It's the y-axis. What is that hitting at y? And it's hitting at -2. So f of 0 equals -2. Okay, let's go to the next one. F of 4. What that means is when x is 4, what is the y value? So 4, 1, 2, 3, 4, find that on your line. Where is that hitting? What's that point? For what? For 2. So the function at 4 is 2. Next, we're going to determine x instead of y. So where the function is -3, or where y is -3, f of what is -3? So I have to come down here to -3, find that on the line, and see which x value that's relating to, and that's -1. So -1, -3 is that point. All right. The next one is f of x is equal to 1. So we want to find where y is 1, right here. Where is that on the line? Right there. What x value does it take to get there? 3. So f of 3 is equal to 1. Let me know what questions you have regarding. If we can write a formula that shows how the output depends on the input, we can use it to define a function. Just like with tables and graphs, we can evaluate or solve functions that are written as formulas. To evaluate a formula, you're going to plug in the given value and you're just going to simplify the right side. You're not going to solve for anything. You're just simplifying it. To solve a formula, that is different. That's when you're going to plug in a value for y and you're going to solve for your input value, which is usually x. Okay. So given a function, g of x is equal to x plus 2. We're wanting to take the -5, it's replacing x, and everywhere there's an x, I want to replace -5 where that x is. And then I'm just going to work my problem straight down. So the signs are different. I'm going to subtract and take the sign of the larger number. So g of -5 is -3. Pause the video and attempt to do this next one on your own. Okay, g of 0. So g of 0 means everywhere there's an x, we need to plug in 0. So 0 plus 2. And that's equal to 2. So g of 0 is equal to 2. Okay, determining x when g of x is equal to -2. So now, instead of plugging in for x and solving, we're going to, well, we are solving. We're solving for x. So what we're going to do is I'm going to rewrite this as g of x is equal to the original function, x plus 2. And I've got g of x is equal to -2. So where this g of x is, I'm going to substitute -2. And now all I have to do is solve for x. All right, so I'm going to subtract 2 from both sides. The signs are the same, so we add them, keep the common sign. So x is equal to -4. Or you could write it as g of -4 is equal to -2. Either one works perfectly fine. Pause the video, attempt these next 3 on your own, then come back and see how you did. The first one is k of 3. So that means everywhere there's a t, I need to plug in 3. So k of 3 is -8 times 3 plus 9. 8 times 3 is 24. Negative times positive is a negative. Plus 29. I'm sorry, plus 9. Goodness. And then positive and negative. So the signs are different. We have to subtract and take the sign of the larger number. So 15. Yeah. So -24 plus 9 is -15. So k of 3 is equal to -15. All right, next one. Evaluate k of 0. So everywhere there's a t, I'm going to plug in 0. So k of 0 is equal to -8 times 0 plus 9. -8 times 0 is 0, plus 9 is 9. So k of 0 is 9. Lastly, we're determining t when k of t is equal to -39. So in this case, I rewrite the function itself, and I do this every time. Where that function k of t is equal to -39. So where this is, I'm just going to replace it with the -39. And I'm going to solve for t. 9 is added to this. I'm going to subtract 9 from both sides. The signs are the same, so we add them and keep the common sign. It's gone. -8 is multiplied to t, so we have to divide both sides by -8, and we do it to both sides because of this cute little equal sign. This becomes 1, so t equals negative divided by negative is positive. 48 divided by 8 is 6. Or you could write k of 6 is equal to -39. I would accept either one. Let me know what questions you have. All right. Linear functions still. A linear function is a function whose graph produces a line. You learned in school to write a line in the form of y equals mx plus b. B represents the initial or starting value. M represents the slope or rate of change. It's not just rate of change, it's a constant rate of change. The rate of change does not change with a linear function. So now we know that y equals f of x. We just discussed that in the previous part. We can now write, instead of y equals mx plus b, we can write f of x is equal to mx plus b. So identify the rate of change and the initial value for the function. So the rate of change, or the slope, is the number, the coefficient, the number in front of x. And in this case, it's 3. The initial value is always going to be your b, and in this case, it's 7. Okay, continue doing that for the next 3, and then come back and check and see how you did. Rate of change for this one is the number in front of x, including the negative, so -10. The initial value is the one without the x, and that is -9. For C, f of x equals to -5x. The rate of change is, again, the coefficient or the number in front of x, -5, and we don't have an initial value, so 0. The rate of change, there is no x in this one, so we do not have a rate of change, and the initial value is 1. All right, one thing that helps students with word problems is changing the direction of the formula to this. F of x is equal to b plus mx, because you have your starting value and then you can add to it or you can subtract from it, but you need to have a starting value. And I show people how to do this on the board. All right, calculate rate of change. So I guess the best way, let me go back here and do this. If say we're going to a carnival, okay, and your family gives you $40 to go to the carnival. I know that's a lot, but each ride is $5. All right, so you go to the carnival. We can use f of x as the money left over, money you have, and then x is money you have after each ride, after x rides. And x is equal to the number of rides you've ridden. Number of rides ridden. Okay, we're just watching. Don't write this down. I'm just showing you why this works better. So if I say, okay, you were given $40, so that's where the B would go. And then are we adding or subtracting that $5 per ride from that $40? We're subtracting it. So every ride you ride, you're going to be subtracting $5 from that initial value. So this makes more sense in terms of how we read. Start with $40, our initial value, starting value, and then we're subtracting $5 for each ride ridden. Compare that to what if we wrote it like you learned in school, and that would look like -5x plus 40. And to me, that doesn't read as nicely. It doesn't make as much sense. You're subtracting $5 for every ride you're ridden, but you're given $40. It's not pretty. It's very confusing for me. So just with word problems, this is going to be brilliant for you. Give it a chance. One super useful formula in math is for the rate of change or the slope. Basically, it tells you how fast something is going up or down compared to something else. So if you're given 2 points, so say you're given point 1, I'm going to label that. When you're given point 2, x sub 2, y sub 2, and this has to do with the sub ones has to do with point 1. The sub 2 just has to do with its point 2 representing it. So if you have 2 points, then you can use y sub 2 minus y sub 1 over x sub 2 minus x sub 1 to find your constant rate of change, all right? Or your slope. And we're going to do that now. Calculate the rate of change of linear functions that contain the points 1, 8, and 4, 17. So before I even start looking for my rate of change, I label these. X sub 1, y sub 1, x sub 2, y sub 2. Okay, now I'm going to plug them in. So y sub 2 minus the y sub 1 over x sub 2 minus x sub 1. You have to start with the same point each time, both in the numerator and in the denominator. So y sub 2 is 17 minus y sub 1 is 8. X sub 2 is 4 minus x sub 1 is 1. 17 minus 8 is 9. 4 minus 1 is 3. And this reduces to 3. So the rate of change is 3. I would like for you to pause the video while we're still showing all of this and do the next 2 numbers, all right? I'm going to go ahead and label, pause the video, do yours, and then come back to see how I did them. All right, so x sub 1, y sub 1, x sub 2, y sub 2, and I'm going to use the same one, y sub 2, negative 14, minus y sub 1, 30, over x sub 2, which is 7, minus x sub 1, which is negative 15. The signs are the same, so we add the numbers and keep the sign. And then its denominator, we've got a negative and a negative, which together becomes a positive. So 7 plus 15 is 22. And then these reduce. They both reduce by 2, but they also reduce by 11. You could put 44 divided by 22 and you're going to get 2. So this is just negative 2. So the rate of change is negative 2. All right, again, let's do this with the next 2. Pause the video and attempt these yourself. All right, I'm going to rewrite this because you can't see the one up top. I'm just going to follow this formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. 2 minus 2 is 0. 10 minus 3 is 7. 0 divided by 7 is 0. Okay, anytime the 0 is in the numerator, it can be divided by any number and it'll give you 0 except for 0. If this was 7 divided by 0, it is not 0, it is undefined. You can put it in your calculator. 0 divided by 7 is going to give you 0. 7 divided by 0 is going to give you an error. Let me know what questions you have. All right, now we're going to tables. So we've got a table here with both x's and f of x, or our y's. We want to determine the rate of change and the initial value of the linear function that generates the following table of values. So the cool thing here is if you're ever looking for the initial value, that is where your x or your independent variable is 0. To find your initial value, that is where your x or your independent variable is 0. So if I find where x is 0 right here, that is going to be 14 is going to be my initial value. So my initial value is 14. My rate of change, I need to choose 2 sets of ordered pairs to find my rate of change. And I'm going to use 0.14 because that's a really nice one to use because it's got a 0. And then it doesn't matter any other number I use. I'm just going to randomly choose 3 and 77. All right, so I'm going to go y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I need a label. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. 77 minus 14 is 63. 3 minus 0 is 0. Oh, 3 minus 0 is 3. And then I can just divide or reduce, and this is going to give me 21. So my rate of change is 21. I can now write a linear function given this two pieces of information. My linear function for f of x is equal to 21x plus 14. Okay. I would like for you, for this next one, find your initial value, find your rate of change, and then attempt to write your linear function. Okay. So I'm going to leave this here. You go do yours, and then I'm going to pause the video and then come back and see how I did it. All right. So my initial value is going to be -6. And my rate of change is, I'm going to choose 0, -6. And I'll choose, let's go -3, 75. It doesn't matter which one we choose. All right, so label. And then I've got y sub 2 minus y sub 1, x sub 2 minus x sub 1. Negative and a negative becomes a positive. So 75 plus 6 is 81. -3 minus 0 is -3. And then you can just divide this. 81 divided by 3. Let me do this real quick. I do not have my calculator. I know it's going to be a negative. 3 goes to 8 2 times 6, 21, so 7, so 27. Now, one of the things you should see is say you have a negative in your denominator. And what if this ends up being a fraction? I just want to cover this real quick, just to make sure you have this knowledge, because I find that most students don't understand this. If I had numbers, and this is just a side note, this has nothing to do with what we're doing here. It's just to understand the information. If I have -3/4, is that equal to -3/4? And is that equal to 3 over -4? And the answer is yes, they're all equal. But mathematically, we tend to show this one or this one and not this one, but they all mean the same thing. Okay, I'm going to come back up here and write my equation. F of x is equal to -27x minus 6. And then let's do this last one. I'm going to give you, I want you to pause the video and attempt this one yourself. Stop. Rate of change is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. My initial value is 62. Because it has the 0 for the independent variable. And then my rate of change, I need to choose a second one. So ROC, I'm going to choose 0.62, and then I'll use 4 to 14. All right, so x1, y1, x2, y2, y sub 2 is 214, minus y sub 1 is 62, x sub 2 is 4, x sub 1 is 0, and you could have used it. You don't have to use 0.62, it's just easiest. So 214 minus 62 can be a 6, 5, so 152 over 4. And then I just need to reduce or divide 4 into 152. You don't have to do this if I use your calculator. I just don't have one in front of me. 4 times 3, 32, so 8. So the rate of change is 38. Okay. Let's write our linear function. F of x is equal to 38x plus 62. Well, let me know what questions you have. Interpreting situations with rate of change. This is a great situation to use the version that I was referring to, V plus MX, V plus MX. And to interpret the rate of change in these situations, the function V of t is equal to negative 5.4t plus 34.2 gives the value in thousands of dollars of an investment after t years. Okay, so if we're going to interpret the rate of change, what it means is if you're starting at a value of 30.4.2 in thousands, so starting with it's dollars, 34 comma 200 because it's thousands, so 34.2 times 1,000. So starting with $34,200, they're subtracting. And I know this because if they'd written it like I did, it would be 34.2 minus 5.4t. So starting with $34,200, it's losing or decreasing, starting with 34,200 and decreasing by, again, thousands of dollars, $5,400 per what? What is T? Per year. So the part that is the rate of change interpretation is the decreasing by. It's the part that's in front of or the coefficient of the variable of T. So it's negative 5.4. We need to know that that's in thousands of dollars. And if the sign is negative, you should use the word decreasing. If the sign is positive, you're going to use the word increasing. I threw in a little bit more to show you, hey, we're starting with this much. And every year, based on this investment, you're losing or decreasing your money by $5,400 a year. Not a great investment. All right. I would like for you to pause the video and interpret the rate of change for the next one. So you're just interpreting the 2.5x, all right? And you can even rewrite this to 25.4 plus 2.5x if that helps you see it better. All right, pause the video and then come back to see how I do it. So I'm going to do the whole thing. I'm going to say starting with $25,400, starting with, don't forget your dollar signs, $25,400 because this is in thousands, and it's increasing and increasing. The part that I'm looking for is this by, don't forget your dollar signs, $2,500 per what? X is months per month. That's nice. So I'm looking for the part that's underlined, that this function is increasing by $2,500 per month. That's exactly what I'm looking for. All right, again, pause the video and do this one. I would like to, again, rewrite this. P of B is equal to negative 338 plus 1.4B. So Paul is planning to sell bottled water at the local carnival. Paul's profit in dollars from selling B bottles of water is given by this formula. So this negative here tells me that Paul has spent some money to buy water or advertising or something because he's negative 338. This is not the part that I'm asking you to do. It's this part, but you need to understand that Paul is now in the negative. He's in the arrears by $338. So Paul starts, how can I say this? He starts having spent, let's do that, having spent $338. That's explaining the initial value. That's what that's explaining. Now, the part that I wanted you to make sure you can explain is it's increasing and is increasing by 1.4, this is dollars, so increasing by $1.40 for every bottle of water he sells. Okay. It's not saying he's selling his water for $1.40, but every bottle of water he sells, he is earning a profit of $1.40. Let me know what questions you have. I'll finish up the lecture in the next video.